All right, good evening. My name is Ben Fulroth, and the title of my final project is making a bench scientist's life easier by leveraging Django and Luigi to create a scientist's benchtop drug database. So, just to give you some background, I'm a scientist. I work at the Broad Institute here in Cambridge, Massachusetts, in the Center for the Development of Therapeutics. And basically, our goal is to develop drugs or therapeutics towards very devastating diseases. For example, I'm on a cancer project right now. Some of my colleagues are on projects that are designed to treat and cure heart disease, inflammation, and many other types of devastating diseases. And so, one of the problems I sought out to solve using my new Python skills was the fact that as a bench scientist, myself as well as my colleagues receive anywhere between 10 and 50 drug precursors for testing each week from our compound management group. These drug precursors, a picture of these are shown here at the top, where they're in little tubes. They come in barcoded plates, and the tubes themselves are also barcoded, as shown right here, which makes them actually easy to track in the sense that we do have a plate barcode scanner and we can very efficiently scan these. But the problem is that most scientists default to using Excel to track these compounds, which results and has resulted in tracking errors and missing information. There's also Excel version confusion in terms of which version that we should actually be using. And so I sought out to create a web-based application using the Django web framework in order to better handle this particular problem. And so again, the fix is to leverage Django web framework as well as Luigi to create a web-based application that a bench scientist could easily use on their computer to track drug precursors for testing. And so, in terms of getting started, I used or leveraged both the cookie cutter that I created for this class as well as the cookie cutter Django cookie cutter provided on the cookie cutter website. I did this to basically bootstrap and codify the best practices in kind of using or starting a Django-based app. I should point out that I tried some other cookie cutter Django apps or recipes on the cookie cutter site. Unfortunately, a couple of those were just too minimalistic, and so I did settle on the same one that we used for PSET 6, which is actually a really great starter. And so that's how I got started. And then the next step was to basically create my backend for the tables that I wanted to create. So I used the same type of process that we use for PSET 6 in that in order to create the object relational mapper, I used the Django model class in order to do that, which is nice in that it's very declarative and that you just declare the fields that you want and the types of those fields. So as you can see, I basically have two tables. I've got a benchtop drug location table, which basically just tracks the locations of all of those 2D barcoded tubes and their respective plates. And so the plates are also barcoded, and we can very easily then figure out where the compounds are in terms of where they are in the actual plates, and that helps a lot. In addition, I have another table called Benchtop Drug Solubility, which tracks the solubility for our compounds. And this is really actually important because in a lot of the tests that we use, if the compounds aren't soluble, then we really shouldn't test them because they can mess up our instruments. And so it's really important for us to be able to have a very quick, bird's eye view of the solubility of the compound to be able to determine if we should test it or not. So to kind of take you through some of these fields, the Broad ID is just our ID for the compound. It's basically it's not a unique identifier, but it is an identifier for our compounds. The barcode is a unique identifier. That's the 2D barcode on the bottom. Well plate, concentration, the original volume, remaining volume are all pretty self-explanatory. MW stands for molecular weight, which we use quite often, and then the date aliquoted. If this is also very important because um, a compound can actually kind of go bad over time, and so I wanted to be able to make sure that I kept that information in my table so that I could query and find compounds that, for example, were only maybe 2 months old, for example. And then in terms of solubility, everything is pretty self-explanatory. Solubility in micromolar is just the value of the solubility. In addition, source, sometimes we test the compounds uh, at a different location other than the Broad Institute, so we'd like to indicate that. One other thing I found that was really important is to indicate this keyword argument verbose name, because this can be used by some of the downstream packages that I'll get into here in a moment. The verbose name can be used, for example, in your table headings in your web page. So that's actually really nice, and you don't actually have to reuse that. So it's a really nice way of doing it once and then having that being picked up in your actual web page. So I'll show that here in a moment. And so aside from creating the ORM, I also wanted to make sure that the files were atomically downloaded using a Luigi workflow. And so I used Luigi to do this. I persisted my two tables in an S3 bucket. I may change this in the future as if a scientist at the bench uses it, it probably would be better to put it on a server, an internal server at a specific location. But at the moment, it's in an S3 bucket. And so I used a Luigi workflow in which I created a tasks module. And then I have basically two different tasks. I have a save Benchtop drug data task, which is an external task. The output of that is basically the path to the S3 bucket as an S3 target. I then have a download bench drug data task, which is basically the task that does the work of downloading the data. And the nice thing is that if I parameterize this by just indicating the name, I could use the same task for downloading multiple files for multiple tables. So in addition, I also created a management or a command that we can use with manage.py, the name of which is called load initial data. I also have purge SQLite database just in case we wanted to purge these tables. It doesn't drop the tables, but it does purge the tables if a user wanted to just start all over. So that's how I basically created those. So the next part was actually a little bit difficult. I didn't think it would be, but figuring out how to best display tables on a web page was actually a little challenging for me, at least. So I originally sought out to use raw HTML, and I don't have almost any experience in HTML. I started going through some tutorials on how to write web script using HTML. Some of it was actually pretty easy, but actually displaying data in tables is actually kind of a different story. It's very hard to do that, at least for me. So I did some research on Django packages and came across quite a few. There's actually a really nice website that lists Django packages here, the link provided at the bottom. So I started off with a couple of these, one tritable, and this looked promising, but after kind of creating some tables and things, it didn't look quite right, and the documentation wasn't the best. So I switched from that to Django Tables 2, which was actually excellent. And so there's a lot of pros to Django Tables 2. For example, it has really good documentation. The way in which you declare a table is very declarative, which is really nice. It's very similar to the way in which we declared our serializers in problem set 6. The default for styling is Bootstrap 4, which is actually also really nice because the styling is nice. And it has a lot of out-of-the-box functionality, but you can also customize it a lot. And I didn't get into the customization, but it does provide a lot of good documentation on how to customize. So I created a tables module, and here are my two tables. So I've got a drug location table and a drug solubility table. As I mentioned, it's very declarative, and it's very similar to our serializer class, where you have a class meta, and then you can just basically declare the model that you're using, the template that you're using, and the fields that you want. And so the template was actually a little tricky because they provide a couple of them. One of them wasn't working very well at all. It was just kind of displaying the fields kind of overlapping. So I settled on the semantic template, which actually looks quite nice. And so the next thing, so I will go through a demo and show you how the tables look, but I wanted to quickly talk about how I went about inserting new data. So this is really important. People want to insert new compounds into the database so that they can track them. So again, I searched around, and I first went through the tutorials on Django, looking at the class form, or the form class in Django, and I found that the learning curve was actually quite steep. I'd like to return to this at one point, or at some point, but it was quite steep for me. Django class model form, it was actually quite good, but I couldn't get it to really display the fields kind of how I wanted. So I went and I searched around, and I found Django crispy forms, which is actually it's already in the Django cookie cutter app. And so I already had it, I didn't know it, but it is an installed app that comes with that if you choose that option. And so this was actually quite good. Some of the pros include some great documentation and tutorials. It also uses Bootstrap 4 styling, and the forms are beautiful. And so at this point, I'd like to take you through a quick demo. So I do have my web page up and running. So I did learn some HTML, and I wrote out this kind of beginning home page here, the bottom of which shows some of the navigation, what you can click on. And so if I click on the drug location table, this is a table that shows all of the drug locations. And what's really nice about this, as you can see, the table is nicely formatted using Django Tables 2 and the Bootstrap 4 templates. What's really nice is that sorting comes with Django Tables 2, so you can sort. In addition, you can sort multiple fields if you want to. And so if I return back, I also have a table for solubility. So if I click on that, that's hitting my database and pulling that in from using my ORM, my models. And so as you can see, I've got my Broad ID, the buffer, and all of the information with regard to the solubility. And then finally, I wanted to show how I actually can add a new drug or add solubility. Both of these are pretty much the same, but it's going through basically using a post request where you can then add in a drug. And just for the sake of time, because I realize that I'm almost at 15 minutes here, I won't show this, but it does work really well, and it adds that new compound to the table. And so one other thing I'd like to quickly go back to my GitHub account. So I did create quite a few unit tests in testing the models for my Django app, as well as the Luigi workflow, so everything is passing. In addition, I created a nice README file for students or for other scientists in my group to be able to quickly get started and install this app on their system. And so finally, I'd like to quickly return back to the presentation and talk about future directions. So I'd like to add the ability to add multiple drugs at once. I did look into this. It's quite complicated, at least for me. So I'd like to be able to add in like 10 drugs. Now, I can do this by using my command, but it would be really nice to be able to have a form to do this. So I'm going to work on that. In addition, I'd like the ability to query a list of barcodes and return those results. I do have that on another branch, but it's not quite prime time yet, but I'm still working on it. I'd like to add the ability to export a query to a CSV file. That's actually possible using Django's tables too. I just haven't figured out how to quite do that yet. I'd like to extend this to the lab so that we could actually maybe deploy it on a web server and have each scientist have their own set of tables, and therefore we could then search across and say, hey, this scientist has this compound or that compound. So kind of make it more global instead of just having each scientist have their own table. So I think I'm out of time, and I just wanted to thank the TAs for taking a look at this presentation and just all their help throughout the semester. It's been an amazing, very challenging class, but I'm definitely better for it. So thank you very much, and good night.